Okay, so today we're going to do a couple just special cases of solving inequalities and then also introduce some word problems. So with the first problem that we have in the top left-hand corner, what we want to do is go ahead and just solve the equation regularly. So I'm going to distribute. On the left-hand side, I'll get negative 3w plus 9 is greater than or equal to 9 minus 3w. Next thing I'll do is get my w's on the same side, so I'm going to add the 3w over to the other side, and when this happens, just like we've done in Chapter 2 and in Chapter 6, my variables cancel out in both sides, and so all I'm left with is just 9 is greater than or equal to 9. And what I have to figure out is whether this is, if my variables cancel out, I just want to figure out if what is left is always true or never true. So 9 is greater than or equal to 9. That is true because it's or equal to. So I know that this is infinite solutions or all real numbers. Anything that I plug in for w will always give me something that is true. So all real numbers would be, all real numbers is kind of like infinite solutions. Whatever I plug in will be correct. And the other one, again, do the same thing. Distribute, get negative 12, minus 2x is less than negative 15 minus 2x. And so again, I want to get my x's over on the same side. When I do that, both of my x's cancel out, and so what I'm left with is negative 12 and negative 15. Again, I want to ask myself, is the alligator eating the bigger number? Is negative 15 bigger than negative 12? That is false because it's negative. So since this is never true means that there's no solution. No number that I will ever plug in there will actually give me something that is true. Then the last one that you have right there before we get to the word problems, again, I'm solving this inequality. The first thing that I would do is something like this is get rid of my fraction. So I'm going to multiply both sides by negative 2. And so when I do that, on the left-hand side I have x plus 5. Because I multiplied both sides by a negative number, I have to flip my sign. So this is one that's a little different because I am changing my sign kind of in the middle of the problem. So I get negative 24 on the other side. And then my last step is I can subtract the 5 to the other side. So I get x, negative 29 on the other side. Again, when I graph this on my number line, I've got my points 0 and negative 29. Do an open circle. And then again, I test my point. So I'm going to plug in 0. Is the alligator eating the bigger number? No, negative 29 is not bigger than 0. And so I know that my arrow is false, which means far away from my test point. So it's going to the left in this case. Okay. When I get to the word problems, I like to try to make sure that when I'm doing the word problems, I'm setting them up I'm setting up what goes on each side of my inequality first, so I know whether I need a less than or a greater than sign. So in this first problem, talking about me going to an amusement park with $30, I want to write an inequality that puts the number of rides that I can go on. And so when I do this, there is money that I'm spending, and then there is money that I have. And then the question we have to ask ourselves is, which number has to be more? Can I spend more than I have, or do I have to have more than I spend? So hopefully we understand that we have to have more than we spend. So I want have to be the bigger number. I have to have more money than I spend. And then I could also spend the exact same amount of money that I have. So spend has to be less than or equal to the money that I have. So I know that I have $30, and then the money that I spend is I get charged $10 for admission, and then $1.50 for each ride. So I start with $10 is my upfront fee, and then it's $1.50 for each ride that I go on. And so to find out how many rides that I can go on, I would subtract the 10 over to the other side, I would get 150R is less than or equal to 20, and then divide both sides by 150. And so I get 20 divided by 150 gives me 13.3 repeating. So 13 and a third. And what we should kind of realize here is that it doesn't make any sense for me to ride a third of a ride. So I want to make this just R is less than or equal to 13 rides. The next problem, you have $18.50 to spend on pizza, and then I got how much each pizza costs. So again, I'm going to set it up the same way. I've got money that I'm going to spend and money that I have. Money that I have has to be bigger or equal to the money that I spend. So I've got $18.50, and then I've got $14 plus 33 cents for each topping. So I can subtract the 14 to the other side. Get 33.33t is less than or equal to 4.5. Then 4.5 divided by 0.33. And I get that my toppings have to be less than or equal to 13.636363636363. And so what's important to know here is since I can't spend more than I have, I can't round this up like the 0.6 would tell me to round with a topping. So I have to round down, because if I round it up, I would spend more than I have. So it's going to be 13 toppings. Okay. Again, when it's a spend and have, I can't spend more than I have. I can't round my answers up in that case. Here we go. Another spend and have. Let's see. I brought $28 into Walmart. So that's how much money I have. I buy a Nerf football for $9.50. And I want to spend the rest of my money buying Skittles. If I brought $28 into Walmart, how much money can I spend on Skittles? So the $9.50 is for the Nerf football. And then I'll do an S for Skittles. It doesn't tell me how much Skittles are, so I'm not trying to figure out how many Skittles I can buy. It is just how much money can I spend on Skittles. So I can subtract that $9.50 over to the other side. And get that my Skittles, 28 minus $9.50, gives me 18. So I can spend $18.50 on Skittles. I can spend less than or equal to $18.50 on Skittles. And then the last one is the only one that's different. So it says Pizza Hut costs $10 plus 42 cents per mile. Pizza from Domino's costs $20, and then it has free delivery. And so I want to write an inequality for the number of miles where the cost at Domino's is less than the cost at Pizza Hut. So I want Domino's to be less than Pizza Hut. So Domino's is just $20, no delivery fee. And then Pizza Hut is $10 plus 42 cents per mile to deliver. So I want to figure out, how many miles is Domino's going to be less than Pizza Hut, and then after that, I know that Pizza Hut will be, that it'll switch then. So when I do this, again, solve my equation, I subtract that 10 to the other side, get 10 is less than 0.42m. Then I can divide both sides by 0.42. So I get 10 divided by 0.42. And that gives me, 23.8. So Domino's will be less than Pizza Hut when my miles are bigger than 23.8. So if I'm delivering farther than 23.8, I should go with Domino's instead of Pizza Hut. If it's if it's less than that, if I'm traveling less than 23.8 miles, I should go with Pizza Hut instead, because Pizza Hut will end up being cheaper for anything under that mileage. So anything over 23.8 miles, I want to end up going with Domino's. Okay, and again, I could round it to 23.8. Because I'm talking about miles, and I can travel 0.8 of a mile. That's okay. Anything less than that, I want to choose Pizza Hut as my place. Okay? So again, just make sure with each of those that you're writing your inequality first with words rather than skipping right to writing your equation. Make sure you know which way your inequality sign is facing.